So if you look at the Qualcomm State of Sound report, there's 5 problems that are typically people are complaining about. The first one is performance, fit dependency, then high frequency attenuation, howling, and battery life. And we are solving 4 of that directly and the 5th one indirectly.
Hey everybody, Dave Lindbergh somewhere in the Caribbean today with a new episode of THD Podcast. Doing something with one of our friends to get them some publicity coming into CES. So we're going to have Elevear coming from Aachen, Germany to join us. We're going to talk about AI-based Adaptive ANC. So we had them on a little while ago, but we're going to find out what progress they've made in this specific area. But without delay, Audio Express, we encourage people to subscribe to that publication. There's a discount code over here. And there's actually an older article on the problems with ANC that Elevear was involved with. So we'll put the link to that old article in the listings below as well. And also our sponsor, the Alti Association, we encourage people to get involved with Alti. They'll be at CES. They'll also be at the High End in Munich in 2025. And they'll also have an audio summit in Phoenix. I think it's in March. But anyways, information will be right here, and you guys can check it out. But without delay, let's get into meeting everybody today. So, Simon Weston in Japan, how are you?
Back at base as usual, unlike some of us.
Okay, and yeah, Stefan Liebich coming to us from Germany. Good afternoon, Stefan. How are you?
Yeah, I'm very good. Thank you as well. I mean, it's good to be on here again.
Okay, great. Yeah, so AI-based adaptive, so this is actually using some kind of information. Is it in real time to process and tune ANC for better results? Or maybe tell us about it. Tell us what you're working on, or maybe start with the problem that you're solving.
Yeah, very much. I'm very happy to jump into this. So basically, we from Elevear, we are launching the first product in our AI-based hearing enhancement series. So that's the AI-based Adaptive ANC, and we basically looked at the problems that people have with ANC. So if you look at the Qualcomm State of Sound report, there's 5 problems that are typically people are complaining about. The first one is performance, fit dependency, then high frequency attenuation, howling, and battery life. And we are solving 4 of that directly and the 5th one indirectly from that perspective. So if you look at what we're actually doing is we are providing different benefits. We adapt to person variation because each ear is different. So we could say you individualize the ANC to everyone. That is addressing the problem of performance at the high frequency attenuation because higher frequencies is more individual. So basically you need more adaptation for that. Then the second one is adaptation to fit. That basically means that if you have the wrong ear tips or if you move your jaw, let's say that you're in an airplane, people probably kind of experienced that before. We optimize each fit to give you the best performance that's possible with this device. So obviously the driver has some limitations, but we get the best out of it. Then the third one that you naturally have in that sense as well is adaptation to the environment. So we optimize each situation. The airplane certainly has a different noise field than the cafe. So if we at CES and we meet there, there's going to be a lot of babble, a lot of talk around. And that's something that you need to attenuate. So higher frequencies, talking, that is something that we're tackling as well. And then the nice thing is that what comes in the package, so you're adapting to all of these situations. You're also compensating for production variation. And I remember we had a conversation about this last time. We said like, okay, in assembly line, people need to calibrate their headphones for each individual headphone for the ANC. And basically we can take over that, make the process easier or completely get rid of it. So do the calibration in field because we optimize each situation anyway, and then allow for the tolerances in the production. So I think that's not a consumer problem, but it's clearly an advantage for the manufacturer. So they would still need to like throw out the devices that are broken because if there's no microphone working, and it's tricky for us. But we make it much easier to get the best performance despite the fact that there are tolerances. And then if you look at the problem as well, so one of the things that we talked about in the article were robustness and also reliability. So what is very special about this one is it's a very robust and reliable adaptation as well. So there will be no howling. So that's the 4th problem in the line. And we will also be still adapting while there's presence of other disturbances that are not in the environment. So typical one, we are talking now and I have my own voice that is active. I need to consider this. And a lot of solutions out there actually stop all of the adaptation while I'm talking. And if you think of intelligent devices nowadays, where there's going to be more interaction, more calls, you can talk to like an AI assistant, you will have more interaction with the voice. So from that perspective, it's super important to also cover this one. And then, so generally from the perception that we had so far, so the actual launch is at CES, but we gathered a little bit of kind of feeling from selected customers, and the feedback so far has really been tremendous. So people said, like, I finally understand where the adaptation brings the benefit, or it's the best adaptive ANC I've heard so far. So from that perspective, because hearing is believing in that sense, I invite everybody to pass by. We're going to show the latest version at CES and come by and listen to it. And just to
remind myself, was it so the interaction with the voice for ANC? One thing that kind of struck me that perhaps this could be beneficial for occlusion effect for like people, the typical people yelling on their headset in an office environment. And if you're adding, that's just with regular headphones, but you add ANC to that, and you're talking on a call or something, normally people raise their voice because they can't hear themselves. So the occlusion effect. Are you talking about compensating for that when you talk about interaction with voice, or is that just one of the issues?
I would say, like, if you talk about this one, there's actually two problems. So the first one is that you want to continue adapting and continue getting rid of your colleagues that are in the background when you talk, right? So you want to focus on your work. The second one would be adding the voice back in, that is myself. And that one is not happening, the one that's over here, because basically the target is to just attenuate as much as possible. So what we are proposing is like most silence, you could say. Yeah. And for the own voice, I said, like, okay, this is the first product in a series of hearing enhancement things. So I will not spoil too much, but I think the problem that you mentioned is very known to us.
Right. Yeah.
Stefan, do you mind just go back a step? Because what is adaptive ANC? Can we just say a little bit about that?
Yeah, I mean, so you have in ANC, you have the two principles of feedback and feed forward. And what you're doing is you have this counter wave that you're emitting. And then assume that in a static ANC case, I know my headphone very well. So I know a lot of ears, I know how it's behaving in certain situations, and then I design the same way that it's doing the processing in every situation, right? So static ANC is basically, you could say there's two filters. That's the easiest version of it. And then you get something that is always behaving the same. That is fine to a certain extent, but it doesn't help you with the problems that, for example, everybody's ears is different. So you would get an average case, which could be like a dummy head, or it could be like a large data set of people. You could have something over there that works very well as a compromise, but it's not giving you the optimum performance. So from the perspective of where we took it, adaptation, what it's doing, it is taking this processing and really individualizing it to the person, the situation, the fit, and everything else.
Do you think that the variation in ear canals and so on is a bigger factor, or is it more to do with different fit? Some people have long curly hair that creates more leakage and others will not.
I mean, so what we discovered is that the person-to-person variation is very significant. And if you're looking at, so when you pass by and you experience it for yourself, we have a static ANC that's very well tuned for a large population, and you can still hear like a huge benefit from there towards the ones. So from that perspective, what does it tell you? It tells you an average case is not enough. So that's my go at it. The fit is still has influence, but the nice thing about it is like we're not like doing a calibration, so we don't put it in the ear, we play a sound, and then it's done once, but we do it constantly. So it's in real time, it's working all the time. It doesn't require you to have like something play back via the loudspeaker. So that's just observing the system and is doing the work in a way.
Okay. And then just a little bit more technical, a lot of the chip vendors are saying we have adaptive ANC capability, and here's an app note. You go through these steps to kind of get it set up. How would what you're doing differ from theirs? Is there,
Yeah. I mean, if you look at, that's also viewed in the article, actually, in Audio Express. So if you look at what kind of adaptations you can do, is when you look at fit, what you can do is there are some companies out there where the products in the market, you put the headphone in, they detect the fit, then they switch to a different filter. So let's say that I'm categorizing this. I have 3 filter sets, 1 for each fit, and then I choose the right one. And then I might have something that is doing kind of, okay, I have something for a cafe, I have something for an airplane, I have something for maybe busy street and so on. And then I choose something from that. That's the first version of where people say adaptive. But it's basically selecting from a database.
And so that type of adaptive is doing some kind of spectral analysis to determine where the greatest energy is.
Yeah, you could say it's doing classification. It knows what the best fit would be from a database, and then it's applying this.
Yeah.
The second thing that you find is that there are some adaptations out there that are very simple. You could say like microphone gains can be adapted. And that one is giving you some advantage, but it's not going to be the big game changer in my perspective. So what is different from theirs is that we have more variety that we can cover, I would say.
Okay, just go back to that one where you say adjusting the gain. Was that kind of like the more or less the origin or the first implementations that were going around of adaptive ANC, where you would essentially increase the gain as the leakage increased?
Yeah, I would say so. Yeah.
And so you look at it, the situation, you assume that the phase component doesn't change that much. You're just losing energy as you increase leakage, and so you just pump up the feed forward gain, basically.
For example, I mean, and the problem with that is, for example, there is much more happening when, for example, the fit is changing. So let's say that the fit loses, you lose the low frequency reply of the driver. And then if you are just having one gain, then it's basically not reflecting what you would actually need to do to get the optimum case. So from that perspective, I think it's something where you needed to make compromises, what was possible at the time. Yeah. And I think as chips are and everything is evolving, this is moving forward. But the nice thing about the approach that we took over here is that we can also fit it in smaller chips. So we have like the first thing that we bring it out with is gap 9. And that has a lot of benefit in terms of the adaptiveness. And maybe you would get like only the best performance out of this chip, or maybe a comparable chip. But then basically smaller chips can also do some things. Yeah.
Stefan, that's the GreenWaves chipset, the gap 9?
Correct.
Okay.
GreenWaves gap 9, yes. Yeah. So, but I mean, what we show at CES is the nicest that you can get over there. And from my experience, what we have over there and how the system is working, it also fits in a lot of other chipsets and devices that are possible there, and also different form factors. So naturally, one of our main kind of targets is the TWS, but also open ear devices nowadays are quite en vogue. And a lot of people want to see something there, and the same principles apply very well to that form factor as well.
Okay. The underlying principle anyway is that it's moving on from selecting between preset filters or adjusting the net gain of your filter into determining a new filter on the fly, essentially.
Yeah, I mean, you can do the fit, so the filter gain piece. So basically, that's more or less inner and outer microphone gain. But so from that perspective, I can't go into detail because there's like obviously some secret sauce for us as well. But if you would be if you look in the literature, you find a lot of FX LMS, FIR approaches. And I don't think that there's so much special about those ones. And then you need to do a lot of kind of flunching in different solutions for the sub-problem. So what happens if the person is speaking, for example, in these cases? Then what you would probably do is you would be detecting that the speech is there and deactivate your adaptation. But I think one of the kind of beauties of the way that we do it is that we cover this all in one holistic approach, and that we still get kind of all of the benefits out, despite the fact that a lot of the deterioration is there on the signals.
Okay. And in order to actually implement this, to what extent is it dependent on the chip capabilities?
Yeah, I mean, we're obviously talking about MIPS and memory then. I think this is something where we typically take it to the next step with the customers in the second meeting. But what I can say is that complexity is so low that it, first of all, gives you advantage that it can fit in different devices. But second of all, it also allows you to clock those slower. So if it's about energy consumption, with an algorithm, basically, it's very difficult to say, like, okay, we are reducing that amount. With the only exception that you can say, okay, if the complexity is low, you can influence the hardware to go slower, and then you can save energy. So from that perspective, I think that's something there as well.
And so this adaptive algorithm, it runs continuously?
That is something where to have all the benefit, it runs continuously.
Okay. I don't know if you've had a go with the Sennheiser Momentums and a Sony XM5 and Bose QC35 in the situation. I found that you're going to comment on the Sennheiser and the Sony definitely have adaptive algorithm of some form. You put them on, you wait 5 seconds, 10 seconds later, then the ANC improves subjectively. The Bose didn't seem to do that. It seemed to be just static only. Is that true? Is that the case?
I mean, it's obviously difficult for me to comment what's true in these devices. But I mean, one of the tests that you can definitely do with all of your devices is you go in an airplane. I mean, everybody's flying over to CES. Take your best devices, put them in your ear, open your mouth, and then see if the jaw movement is there, see how it reacts to the environment. Then you can, for example, very quickly hear which of the devices are adapting to this particular piece, which is the fit adaptation. And some of the devices do more, some do less, I would say.
The reason I asked the question, it's not easy to tell just subjectively, but it seemed to me that they only that ran an adaptive fit or whatever, one shot, perhaps after you just start wearing it. And after that, it didn't seem to change anymore. Is that a kind of one strategy and you do a different type of strategy? Is that possible?
Yeah, I mean, it's possible. I mean, we could also just run our stuff at the beginning while powering up. But I mean, to be honest, like the big benefit comes when you're always optimizing, in my opinion. Yeah. So it might be something where the kind of reluctance is there because of battery life. But at the same time, if the algorithm is very small footprint, then might be actually because the benefit is big, then it might be a good discussion to have. But I mean, where you certainly see that there's a lot of adaptation happening is the AirPods Pro, AirPods Pro 2, AirPods 4. So basically, that one, you definitely have a lot of stuff that's going on.
Okay. You mentioned about fit and the individual ears. Then there's the other side of it, which is the environmental noise.
Yeah.
And so that's another thing. And why does that make a difference? What noise is outside?
Yeah, I mean, you could say that if you are considering the human perception, right? The human perception has like certain frequency ranges where it's very sensitive. So, and you could say that if there's no energy there, so around 3 kilohertz, for example, where there's the maximum sensitivity, if there's no energy there because you're in the airplane and there's nobody talking, and you just have this low frequency rumbling, why do I need to spend effort to do something at the 3 kilohertz part? So over there, my argument would be that it's nice to have kind of the best kind of static and attenuation part, but if it's not necessary in the situation, you're actually wasting part of your resources. So from that perspective, going towards something that is kind of fitting to the situation has more benefits than in the area where you need it. And even if you look at kind of an average case, then let's say that you have the airplane, it has very, very strong low frequency part, but then people are talking as well. There's a baby crying in the background. We all know the situation. And then over there, they need to make a different compromise, right? And then if you are already set into the setting for something that's designed for the airplane, this part is actually ignored. So I think that is where the magic comes in, when the situations that are out there are so diverse that you need to have something that considers this.
Especially from a consumer's perspective, that ANC has been really heavily driven by travel users. Like the Traveler with their Bose QC35s was kind of the thing for several years. I mean, it still is a bit, but so yeah, like the ability to adapt based on what noise is coming in is definitely seems like a feature customers want. Sorry, Simon, you were going to say something.
Oh, yeah. There's an element to it. Is it true that you can't just realize any filter you want? So if you have predominantly low frequency noise, you could set a filter that provides the correct gain and phase in that frequency band. But it's not possible for it to have exactly the right gain and phase in a higher frequency band. So you trade off one or other depending on where the environmental noise energy is.
You can say that, I would say. So in an ideal world where you can control everything in a simulation, in all of these papers that are doing FXLMS and show nice results, a lot of times a lot of things are linearized and assumptions are made. But if you're in a real system, then there's a certain filter structure that's in the chip. You have like limited resources in terms of the filters, so it's maybe just 6, 8 gains, 4 gains, biquad stages that you have, for example, and then you need to make fit with those. And then just from the principle, you could even design an ideal filter and see where it should lie. But maybe the amount of filter coefficients you have is not able to kind of really approximate it. And then the thing comes in again, is like you make an assumption on what are the main situations that a person is going to be in. So maybe it's a travel headphone. So I really want to cover like where the person is spending most of their time. But then there are some situations which are especially annoying, and then you cannot go over to a different one there. So you're compromising. And I think that's the case, especially for static ANC, where the principle that we bring to the table is actually getting rid of that over time.
Okay. I'm curious about another thing. So once you get into relatively high frequencies, kilohertz, let's say, you have relatively extreme differences between the signal on left and right channel, etc., distance between your pickup microphone and the actual air. And how do you deal with that part of the range?
I would say like some of it is actually secret source. But what I can say is that certainly doing something in the higher frequencies is difficult, because individual differences. So let's say that I'm pulling out, it can be even one side. So I'm pulling out my headset a little bit. If it's a TWS and the fit is not exactly the same, there's large differences from person to for one person already. Yep. So it is super important to know the situation that you're in, and that's what we are capable of, to observe what situation we are in, and then make the right decisions to, in the end, replay a sound that is canceling it.
Yep. So if you have just for example, you have noise coming from one specific location constantly, and that has certain high frequency content, you could actually do something about that adaptively, because you could determine that the phase requirement is different than if it was coming from a different orientation. Is that
Yeah. I mean, one of the things I talked about reliable adaptation. So one of the things you don't want to have is that, let's say that the sound comes from a certain direction, and then you're attenuating this, but it's maybe closer to one ear than to the other. So this one's shutting down, this one is still keeping open, and then the sound source is virtually moving, and you have no association anymore to where the things are. And this was one of the considerations in the way that we did things. So even just saying like, okay, I have a benefit, I can do something, but the benefit is bigger on one ear, and then you're adapting and then everything breaks down, I think it's also a tricky part of the problem. Okay. I would say directionality is both at the same time is helping you, but it's also being tricky because of the binaural processing that a human is doing.
Right. Yeah. So you definitely need to massage it a little bit to make it practically nice.
Yeah. And I assume that some of the principles out there are not in products because they still have one of these big problems in practicality.
Yeah. I see people publishing their ANC performance, and they have some kind of spectacular level up to 3 kilohertz, and I think it's nonsense. If you have one specific, the speaker in one location, you measure it perfectly. Yeah, you could get that in principle, but in practice, it's nothing like that at all.
Yeah, I mean, a lot of times with measurements, it's tricky to say that it's so reliable because it always depends on the situation that's actually considered. So, like good comparison that are in out there for products is also always indicating how the measurement was done. And then for a consumer, it's obviously difficult to rate if that is meaningful or not. But I mean, for our side, that always helps us to know what is happening over there. And still in there, you see sometimes that there are measurements where you think to yourself, like, okay, this can't really be, and you have no idea why that should be happening, right? So if in principle, if I know everything of the system, I can certainly get even better performance. Then you can go up to like 10 kilohertz, 6 kilohertz, something like this. But that's not workable, in my opinion. Yep. So the expectation that you can do something in that sense, it still needs to be reasonable and really work for a large variety of cases.
Okay. Do you face the problem that people will ask you, what's your dB level or what's the measurement? And it's very difficult to give a concise answer.
I mean, so it's also a question of like a total insertion gain, active insertion gain, how much can you attenuate, what's the bandwidth? There's a lot of parameters, and in my opinion, it's very difficult to compare things when it's not on the same device, for example. Let's take the different manufacturers, right? So Bose is always building really good acoustics for ANC purposes, and they're tailoring that. Then other manufacturers might be more focusing on music quality, and they want to make sure that the device also sounds nice when the active system is not working, so there's no equalizer on it, and so on. So you have really two totally different approaches on how to do that. And if you want to get maximum ANC performance, certainly designing the acoustics for it is something that helps a lot, and it makes it more feasible. Mm-hmm. And then in the end, it will always be a combination of passive attenuation and active attenuation. So if we're talking about like what can we achieve, I can also throw out very impressive numbers that are achievable. But in the end, I would say that the real impressive part comes in when you experience it yourself. So that's one of the issues with things that you hear with your own ears, and that's very different from person to person, is you need to make sure that it actually works for you in the best way, right? And no review is going to change that.
Yeah, ultimately, it's a subjective experience, isn't it? Then you just mentioned it right there. Some you'll have customers that have headphones that are woefully unsuitable for ANC, and I mean, how do you deal with that?
I mean, to a certain extent, what we can do is we can analyze the capabilities of such a device, so that we know, okay, this one is a tricky case, this one is something that is easier to deal with. We don't do acoustics, so we don't do like an acoustic design for somebody, but what we can do is also an analysis of how could we improve the situation. And sometimes it's very practical things. So let's say that wind noise is a problem, then it's about the mesh on the auto microphone or the position of the auto microphone. Or you have like some problems with body conducted sound. That might be a problem also of like placement and vibration decoupling. And there's a lot of different things that need to be considered. But also in terms of just the pure performance, also there we can help to a certain extent. And then it depends on when do you come in the process of product launch, right? So is it still possible to do something? Can we guarantee like 10 dB more attenuation if they change the microphone position to what we defined? Okay, then maybe that's worth it. But sometimes it's just you come in different stages, and at some stages things are there and you get the best out of it that's possible. And expectations are almost for everybody wants to have like the best system, right? Yeah. So from that perspective, I think there's also a learning curve where people say, I accept that this is the best we can get. And then to some extent, the algorithms are helping. So what we see with adaptive approach, especially for people, is bringing you a big benefit. So it's really noticeable. But at the same time, if like the headphone is not allowing for it, the benefit will be smaller, right?
Cool. And this point about traditional static case, we call it static, means you decide the filter in advance. And you have the process of production trimming where you adjust for the variations in components, driver and microphone sensitivities mostly. Could you just emphasize a little bit more about how adaptive gets you out of that problem?
Yeah. I mean, so there might be something about sensitivity. So from that perspective, there is like just an offset on what you want to have. And because the system is observing what is happening and there's certain expectations, it can it can control the situation and compensate for that. So within the algorithm itself, there's something that is determining what is different and is then adjusting the system to that difference. And as I said, like if let's say the microphone is not working properly and the sensitivity is just like outside of the bounds of your production tolerances, then obviously there is also a limit for that, because you cannot heal like electronics. But at the same time, if for example, let's say that you have a 3 dB tolerance, right? And then there's some are at the upper end, some are at the lower end. Maybe your golden design is more in the middle. Then what you would normally need to do is you need to adjust all of those to get the best performance. And for us, the system is doing it by itself.
Okay, but you still need, let's say, your internal feedback microphone as a reference. You still need that to be quite accurate, would you?
We can actually deal with quite a bit of differences in the components, but it still needs to be representative, as I mentioned. So I would say that recommendation at the current situation would be that you are still doing kind of basic tests with your device, make sure that everything works, and maybe bring it to a certain level. But then basically the system is doing all of the fine fiddling, which is giving you the extra 10, 20 dB of performance. So the increase in terms of from where you are to what you can get you is very big still. But so that's the reason why I mentioned, like, maybe you don't get rid of all of the calibration, but you can certainly do like the real in-field calibration then later in the live situation.
Okay. And to what extent can the adaptive system handle this situation where you have quite often the speaker will have a port or a mesh covered port on the end, but those two frequency points might be difference between left and right. You know, like one side's got a battery and then so on stuck to it, and it just shifts everything. Can the adaptive system kind of compensate for that to any extent?
Yeah, I mean, so far what we saw is that when we had devices where something occurred, that for example it was a bit clogged, is that it was possible to equalize a little bit the left and right. There will also be limits to it, to be honest. I mean, so if let's say that the mesh towards the ear canal is completely clogged with cerumen, then all of the manufacturers will recommend to you clean your device regularly. You see it with Apple, you see it with all the hearing aid manufacturers that have like microphones and speakers somewhere. So, I mean, physics are still there, and AI is obviously a nice thing. We went for it because the performance is better, but it's not going to be complete magic in terms of those problems, right?
Yep. No, I just kind of get the sense there'd be a lot of manufacturers of lower cost headphones that'd be looking for a kind of solution that can bring them up to a decent level, because in that lower cost range, you've got quite a bit of variability. You often don't have tight controls over response of things, and you end up with just abysmal performance for ANC.
Yeah. I mean, this is one of the kind of advantages, I would say, that it can come from the high end, where it really elevates a manufacturer to amazing performance.
Yeah.
But it can also help people at the low end with like slightly different configuration, I would say. So from that perspective, there will be, and you have this with a lot of chips as well. So there's basically a chip, and then there's like a stripped down version of that, which is a bit lower cost, so that you can actually bring it into further things. And I would assume that at a certain point, we might also have something like this. But at the moment, what I would say is like, it will be covering a wide range of applications, but it definitely brings up the performance significantly. So you could say it takes like a mid-range product and actually makes it a high end. I think that's a very decent thing that we could throw in there. If it takes like a super cheap, no control, cheapest chip, cheapest component thing, then I would say like give us a little bit of time, and we will also get there to help them. But maybe it's not the kind of the first focus.
Right.
Yeah. Excellent. And what do you need to be able to implement it in terms of chips or software support, etc.?
Yeah, I mean, so at the moment, we have it already on the GreenWaves Gap 9. That was the platform we developed it on. We have other chips in the pipeline to port it to. So basically, that's something that happens over time. Certainly depends on customer needs. So if there's a customer that says like, okay, I love this, I want to put it out in my whole kind of product range, then this will be something that's driving the decision, which is the next one. But I mean, as we're talking about, is basically the conversation we have is pre-launch. It's going to be launched at CES. We're first going to observe what the market is saying to this. I see from the first feedback that we got that it's very, very promising, and then we'll take it from there. So I would say the box is still open. What might be the platforms it goes to? What we need in terms of software is it's basically we program a lot of things in C. There needs to be capability for ANC. There's hi-fi cores in almost all of the devices. I don't think that there's a lot of restrictions that we're actually facing. So from that perspective, it is a job that needs to be done on the technical side as well. So it needs to be integrated. It needs to be maybe tailored a bit to the platform, because every platform has slightly different capabilities. But the general basis that we have, particularly for this approach, is quite wide, that enables all the devices.
Yeah, I'm kind of asking from the point of view, there'll be some high-level brands that will do their own firmware in-house. They'll have a software team. And for them, it's probably very manageable. There's a smooth understanding communication. But then there's a whole lot of brands that use factories and design houses. And they say, oh, we would like to have this capability, but we don't know anything about software. So
but this is something... Yeah, this is something we anticipate. I mean, you've seen a shift from software providers that they don't only talk to the actual brands, but they also talk to the ODMs and the design houses. We have conversations ongoing there. I can't reveal them yet, but that's something that is coming up. So certainly in the strategy of rolling this out, part of it is also to use ways to scale easier, I would say. And then it's also, I mean, it's something where if there's and I've heard this many times in the conversations that ANC has been a problem. People have gone through the design, the product is coming out, and actually the performance is, nobody's satisfied with the performance, but then people always say it is what it is. So from that perspective, I think if we come in there and we say okay, we can take over the ANC part, we can help you, and this won't be a problem down the line for other products as well. I think that's a big plus.
Mm-hmm. Okay.
Excellent.
Yeah, I would predict commercially that this kind of echoes what they did with TV speakers, because TV speakers, it was like a sacrifice in a real penny pinching market. So then the DSP companies like SRS and Dolby and all these guys started putting their functionality into TV to produce the acoustics better at a lower price point. So my prediction would be that the mid to low end guys are going to be all over you. So that's my market prediction for the day.
Yeah, I mean, I would agree. I would say the mid-range guys are probably going to be the ones that have the biggest benefit for at the beginning. And then we will be also looking at the low end, because it's going to be a higher volume. And in the end, it's a licensing business. So higher volume is always nice for us. And then it's a different conversation of how to bring it out there. Good
one.
So
then basically... if I might throw this out there, invite CES 2025. We're going to be exhibiting with GreenWaves and with Sonical, so there's going to be 2 suites where we're going to be available. And reach out to us, and we're happy to give you a feeling. Bring your best comparison. So basically, I invite you to take the best headphones, best in-ear that you have, and that you want to compare it to, and then you can see what the system can do.
Okay. Yeah, we'll put some information down below for everybody to check that out. And So Stefan, thanks for joining us today, and thanks everybody for watching, and hopefully we'll see some of you people at CES or somewhere else next year. All right, take care.
Take care. Thank you very much, Dave, Simon. Have a good one.